Thank you.
Goodness.
Okay, friends, I'm Peter from Brazil. You see the Christ behind me. And first of all, I want to say thank you very much to this incredible man who I admire so much. Charles, we are following all what was in Charles' mind. We are trying to make what he understands as computing language, which I love so much, FORTH. Then I want to say thank you to all these incredible persons from SVFIC around the world. Without them, no hobbyist would be programming in FORTH now. So I thank you very much, SVFIC from USA, FIC Taiwan, FORTH Gesellschaft from Germany, Russian FIC, Dutch FIC from Holland, FIC UK England, and every other people in the world to help, that is helping Free FORTH. Lots of thanks to my teachers. Tom Zimmer, I have no words for his work and how much kind, he's a wonderful person, always helping the community. Dirk Brühl from Germany, with all his work inside the community, an excellent man. Thank you very much to Dirk. Jos Ven, when I went back to FORTH a couple of years ago, another incredible person, always helping the community, and an incredible site. He will later show you. And Dr. Chanson Ting, forever. All what we know as hobbyists in FORTH is thanks to him and the wonderful SVFIC. Here are my friends from the Facebook group. Michelle, who is now creating this Zoom meeting. Wesley from FIC Taiwan. He's the bridge to the FIC of Taiwan for me and other friends. Jorge from Brazil. He helped me a lot. Neil from Scotland, an incredible person also. John is going to talk now. Garth, always helping everybody. John Peters, another mentor, fantastic, the work of John. Tony Lewis, I don't know if he's in the meeting, probably he's not. He had a problem, another incredible friend. Cecil Bayona helped us in the beginning of this group very much. I thank you, Cecil. Iruata, the same, from Brazil. Abraham Moller is here. He will present, another fantastic guy. Quentin Quadrat is also with us, another incredible young FORTHer. And Pablo Reda from Argentina, he will also present in this meeting. So now we start with John Hardy from Australia. Hello, John. Now I stop here and we go to John.
Okay. Hello, everyone. This is an honor to present to the first of these. Hope there'll be many more. I guess I want to just start by introducing myself in terms of how I got into FORTH and my general history with regard to systems like this. I've been basically, it started probably not long after sorry, the background's not going to work too well. Let me just turn off my fancy background. I think you can see it now. This is a computer that I produced in the early 80s. This is actually the original finished one called the Tech 1, which I, in collaboration with a friend of mine, Ken Stone, put together a computer kit in the early 80s, which was published in an Australian computer magazine, not a computer magazine, electronics magazine, because that was what what was the norm in those days. And from there, it was part of a general interest in microprocessors and 8-bit computing. I'll just share my screen. Just hold on a second while I bring up my, just need to share the screen. So here we go, I think. Can everyone see my screen? Is that, I don't know what screen I'm sharing, sorry. Hold on a sec.
It's still your still picture. Your last shot where you were sitting in this cafe is still visible.
Okay.
And I have a rotating pizza of doom, and it says John Hardy has started screen sharing.
Okay, that's not really working. So I'm going to stop the share and see if I can get this working. Okay, all right.
This is better.
That's somebody else's screen. That looks like Garth's screen, to be honest. Hey, Garth, can you stop sharing your screen?
Ooh, interesting stuff.
Okay, this is all good stuff, but that's for later, I think. Can I get the screen back? I'm not sure.
Michelle, can you help us with stopping Garth's sharing?
Okay, all right. I'm going to try again. Now, just hold on. Okay. Let me try that again. I think this will. Is that sharing?
Yep.
Yes, yes.
Yes.
Okay. You should be seeing the front cover of the magazine I published. Constructed a kit, and we published it in 1983. Did most of the work in 82, and essentially that went through the Australian market and was quite successful. It's a Z80 based system that I'd been working on for a number of years. In the lead up to that, it was my first computer, effectively, because I couldn't afford computers back in those days. It was successful in the sense that it introduced a number of young people to computing. They built, and a lot of people started their careers in hardware. And I've had many people tell me that, you know, it was influential in their lives. The magazine.
Tell them how old you were when you designed it.
Yeah, I was 19 at the time. And this is, you know, a different era. You can see these, you know, electronics magazines, they don't really exist the way like that anymore. There's many different resources that are available to people today, but the world of that time was a shortage of information. And so to be able to do things like this, you know, you could actually generate quite a bit of interest within your market. So here's the original magazine, and you know, we were basically explaining to people how computers worked. So you can see here, explaining what a CPU is, explaining what how programs operate, and so on and so forth. So I just sort of give you that as a bit of a context, because I was impressed and surprised to realize that 37 years later, there was still quite a bit of interest in this kit, because there's been a second wave of people, makers have come into this market, plus people who were there the first time around, like Mark, who have picked it up again as a bit of a hobby, that people are going through these old magazines that are all archived and software repositories, which have been preserving these pieces of software that have come from that period. And so people can put these things together, and it's got its own interest. So that's been a thing. And so I came back to computing in 8-bit after a break of 30 plus years, having not thought about the Z80 a lot. And then thinking, well, what can I do with the Z80? And what can I do with, trying to bring some software to my old computer, which was really an electronics project more than a software project. In my later career, I've moved almost exclusively into software. I started in hardware and moved more into software as computers became more powerful. And one thing that I came across very early on in this period was I learned about Forth and read, a big text about it, the famous one that everybody knows, and thought, this is fascinating, but I wasn't able to do much with Forth in the 80s. When I came back to thinking about what I could do with 8-bit computing, Forth came back to my thinking, and that's when I started to develop an interest in Forth. So I'll just mention that the Tech1, which is the name of the computer, is now got quite an active Facebook community, and so basically we've got people sharing. We've got people sharing their projects and so on. You can see there's quite a few people have got their own Tech1s operating. We've got a software repository on GitHub, and we've got a software emulator, which is probably easier for me to demonstrate just briefly. It's a simple hexadecimal entry system.
The last page of the magazine, I don't know if it's supposed to have.
Are we still there? We're not moving?
No, we're still on the last page.
Okay. All right, then that's fine. I'll have to manually move things around. I will try to, I see. Okay. That would explain why I was seeing something. So just bear with me while I just try to move some of my screens around, because I'll need to. Okay, so I've stopped sharing. I'll just skip some of this stuff and just move straight to where I went with Forth.
I saw your cursor moving, so I think we were looking at the right screen.
Yeah, I think the problem is I've got lots of desktops. I was thinking I could just flip between desktops and it'd be like a slideshow. That doesn't work. Okay, don't do that. So, all right. So one thing I did was in this year, in the last 12 months, decided to implement a version of Forth, because my goal was to try and make a version of Forth that could fit into the smallest possible space. My goal was to make it fit within 2K of Z80.
Wow.
That's a little tight. I'm now currently at 5.3K, and that's, so I'm probably going to have to settle on an 8K size. But and I'll just bring this up as to give you an idea of what it looks like. This is running in a software emulator. So it's compiling now. Here we go. All right, now does that green text show up? Can people see that? Cool. All right. Well, then just to demonstrate it, it's a Forth. I'll do the obvious stuff. So you can basically do most stuff in it, but I won't say. Since I completed this level of it, I've been getting more interested in just more what I can do with virtual languages and virtual machines in general. So anyway, the main thing is this Forth implementation, which I called FORTH, as in named after the Firth of Forth in Scotland, which you will see an interview with Charles Moore, with this bridge in the background. Sorry, I'll just move that out of the way. With this bridge in the background, that's the Firth of Forth.
No, we don't see the bridge.
You can't see the bridge?
Nope.
Sorry, okay. All right, here we go again. I've made it. Let me just bring that up in this window. Okay, So here we go.
There we go. Yep.
So lessons learned about Zoom here. You'll see an interview with Chuck Moore being interviewed in front of this bridge. It's a really good interview on YouTube. It's worth. I shared it once with the group. This is the GitHub repository for FORTH, which is my Z80 FORTH. It's got a bit of a description of what FORTH is about and the reasoning why I did it and how to program in it and so on. It's still a work in progress.
Sorry to say, it's been 10 minutes.
Okay.
Okay, for sure. All right. Well, I'll wind up. Yeah, that's fair enough. So anyway, that's my FORTH. That's probably it might be a good place to leave it there. I was going to go into WebAssembly, but I think given the time constraints, it's probably better to cede the floor to the next speaker. So
hopefully we'll
Perfect.
have another meeting in 1 month.
Yes. Excellent.
for sure. Okay. Thank you.
Thank you
Thanks, John.
very much. Now we are going to Rob. Rob, are you going to say hi to the group?
Yeah, now we're unmuted. Good.
Hello, Rob. What are your projects now in FORTH?
Okay, Peter. Yeah. Actually, I'm pretty new at FORTH, so I don't have a lot to say on that particularly. I'll just go on a little bit of my background first. So I became a computer engineer in 1978, which is a long time ago, and started doing software and firmware in the late 90s and early 2000s. My last employment was working with the MSP 430, the Texas Instruments low power chip. And around that time, 2011, I became interested in this this gadget here. Can you see that? That's the green erase.
Michel, can we zoom into Rob image?
Oh yeah. Okay, we're still looking at you, are we?
Is Michel
No, we
there?
can see. Yeah.
Ah, no, that's John. Hello, John.
I can see you guys. I can see you, Rob. Fine. So.
Oh, well, I've got you on the screen at the moment, John. I don't know what's going on.
Oh, that's because
there.
you probably got me pinned. So just right click on my or change the option to unpin the image. Maybe I'm not completely sure what option
Yes,
you have
I
there.
need Michel to help us. Michel, are you there?
Yes, the best is
to active
only the intervenant. But for the lag, I can.
But we can see you, Rob. So I would just carry on.
Mouse around the borders and something should pop up around the borders where you can't normally see it.
He's using an iPad, so I think that's the reason.
Hello, Howard.
All right,
It's Peter. Hello, Tom. This is our special guest from Texas.
Hi, Peter. This is so cool to see faces and put faces to the names. All these famous people from Complang FORTH. No idea what they look like.
Yes, wonderful. John, hello. John Helmers. Don is here also with us. Mr. Shubnikov, I don't know you. From where? Who else? Where are our Taiwanese friends? Roland Herrera, hello. Nice you are here. Bill is also with us, Bill Ragsdale. Now, I wanted to present you the Taiwanese guys, Shiliu Sheng, but I don't see where he is.
Dr. Ting, you're going to have to unmute again. Dr. Ting, unmute.
Shiliu Sheng, can you unmute?
Okay, okay, I can hear you now. Yeah, okay. This is Shiliu from Taiwan. Yeah, hello.
Hello.
We can't see your camera. Are you online?
Okay. I didn't set up my camera, but let me see. I will.
It's okay if you share screen or something.
Oh, okay. I can share my screen here. Okay, let me see how to share my screen. Share screen. Okay. Okay, which one I should select? I think this one.
Yes.
Okay.
Excellent.
Okay, then start. Okay. So it's my turn to present, Peter?
Yes, please. Go ahead.
Go ahead.
Okay,
Good.
okay. Okay, this is a brief introduction of Taiwan Fig. And this is a hello from our Taiwan Fig members. And this picture is last year, our annual meeting. Okay. And okay. On the left here, can you see my
yes.
Yeah, we can see cursor.
mouse point? Yeah. This is our chairman now. It's Daniel. Okay. And the Wesley is here. Here's the Wesley.
Oh.
Yeah. Okay. And Dr. King. Dr. King. Yeah. And the others I shall introduce later. Okay. And okay.
You, and your picture also. You.
Oh my.
Where
Where's my? Okay.
On the right.
Yes. Okay. Sorry. Yes. I think I'm on the right, but now I.
You are on the right.
Okay. Okay. You can recognize, but I can. But yeah. Okay. How? Okay.
No problem. No problem.
Okay. Yeah. Okay. Taiwan Fig is officially registered because our government has some regulation. If we want to register, there is some paperwork to do. So actually, we registered very late, about 2012. Okay, but activities actually begin very early, as early as 1985 when Dr. Ting's come back to Taiwan to teach, and monthly meeting began. But there are some sometimes because people go to abroad or something, or go to study, so there are times that the activity did not continue, and there's a strong activity during I think it's during 1985 or so in the National Chongshan Institute of Science and Technology. Is run by the Defense Department. And this is the Chinese web page. And there we have, because there are sometimes funding from one of the chairmen at that time. And he organized very well. And we actually invite Charles Moore to Taiwan to do some presentation. And this is our Google group. So sometimes we can discuss fourth issue on this platform. And this is our Google site. And we have some publications, but not now. It's in the CSIST era. We publish some Chinese journal, and in the time of 2012, we tried to because I teach in university, and I try to apply a project. It's called Teaching Resource Project, and I'm teaching about mechatronics. So I have a plan. I have a project to including the electronics and robot card and the FORTH. So we have a series of activities, and at that time we invite Dr. Ting to Taiwan, and from that time we try to apply for the officially as a
4 minutes to go.
Oh, okay.
That's
And
plenty of time. Plenty of time.
Okay. And at that time, Dr. Ting presented his 328 E4 system and for our project. And this is his documentation for the 328 E4. And now he's, I think he's more concerned with vitamin C, and and this is his new book in Chinese, and this this just demonstrates his concern, and this Mr. Chen, and he is actually a very important key member in FIC Taiwan, because he is the one who consistently hold a monthly meeting so that our group will continue. And he has a GitHub, and he there are several works you can try to understand it. For E4, he tried to get set up a cloud-based terminal, so that you can communicate with E4 on the cloud. And he has a one-word JavaScript, and using JavaScript to set up a virtual machine where you can implement a FORTH there. And recently he's working on ESP32 E4. Okay, and then this is his work. You can see the Chinese FORTH instruction. So here is all here is the Chinese Chinese words, Chinese FORTH words, and this is one of the benefit of Chinese. You can localize the language, and this person on the web, his name is YAP, and the importance is his work on Sana search engine, which is only written in developed in C, but then it's a FORTH language.
Sorry to say 1 minute.
1 minute.
Oh, okay. Okay. So here, okay. Oh, okay. And this is his work. Okay, and this Chinese character, which is composed by the engine. And okay, and this is another person's member's website introduced the Sana Forth. Okay, and one of our chairmen in the CSST, he has a web page, and this is blog, and this is Dr. King, his Facebook. All here, I put the link, so if you like to see, his Facebook consists a lot of document research, so it's a very good source to.
Dr. Sheng, Dr. Shiru
Yeah.
Sheng.
Yes.
Where is HC Shen? Is he going to show us a video?
Oh, I don't know. Did he?
I can't find him on the meeting.
Oh, okay, okay. I don't know because okay. I think I probably okay. This is our project to make a 328 system on a board and fit on a robot card here, and then we have a competition. For example, 15 seconds to go to the end, and how precise your time will decide who is the winner. Okay, so okay, this is my brief introduction here. So
thank you.
Let me yeah, okay. Let me okay, where's my screen? Okay. What I should do now is to sorry, okay, so I should stop sharing, right? But well,
you did already, it's fine.
Okay, thanks. Okay, thank you very much. Yeah.
Peter, you got to unmute yourself, Pete.
Hello?
There you go. Yep.
Ilya, are you there?
Hello? Can you hear me?
Yep.
Yes.
Hello and buenos dias and good day and I don't know what else.
Oh, how are you?
Are you ready to see my 20 slides?
Yep. We don't
Okay.
see you. Yeah, your face is not here.
You can start, Ilya. Go ahead. From Moscow.
Yes, I am in Moscow. Okay, can you see this?
Yes.
It's working. Very good.
Okay. Okay, so hello from Russia.
Hello.
До свидания.
Hello.
Oh no, it's too early to this. Okay, first, I don't know, are we Russian Fort interest group or not? We never asked this. We have an official site. It's started at 26 by my friend Ivan Makachenko. Suddenly he dies several years ago. So I keeping this forum. We have more than 300 users and nearly 50,000 messages for now. So you're welcome. You're welcome. It's moderated, no spam. I can read every message for now. English is not a problem for most Russians, so you can use this platform to discuss. Okay, for what we are using FORTH? For everything. For in last 20 years, we have our own translators, FORTH CPU in FPGA, devices in production and software, but we are not a software group. Now we can collect about 10 photos in one room. We are our engineers. And it was started 20 years ago when I, with my friend, make a decision. We need an engineering team to produce electronics. Our FORTH translators now is fourth generation. They are shown here. At the end of 90s, I create protected mode FORTH. It's derived from SP FORTH when I called to Andrei Cherezov and starts a discussion. How do you plan to switch to protected mode? He answers, no, I want to switch to Windows. Okay, but you can take SP FORTH and use it for it's open source. Okay, it's open source. I switch it to 32 bits, protected mode with linear frame buffer, with assembler, and I don't remember how many projects we done with it, tens maybe. It was a killer feature. We have linear address space and more than 64 kilobytes of memory. A long time we lived with my Quark FORTH. It runs under Windows, written in flat assembler, floating point, and OpenGL. I prepared some pictures showing how it works. 3 years later, we created a C++ FORTH virtual machine, indeed for just one project running under Windows and Linux. And right now, we are working on 64 bits Quark virtual machine, also C++, also included file, and uses Windows 3 to run several virtual machines in parallel. Okay, this is our Quark. It's intended to be used for embedded programming. So it's cross-compiler implemented in pure Quark FORTH. So it's assembler. Where it's assembler and FORTH with no single line of another language. This is indeed it's a much program to create high-order kernel function for digital signal processing. It's not too pretty looking, but it can create. This is wavelet transformation of Doppler signal. You can see rising speed of obstacle. And this is software-defined radio. It's time and frequency, and several sources of radio frequencies are shown in real time. Okay, no more than a toy. The only things to show is we can use FORTH as a framework under OpenGL interface. It's about 100 lines of code, about 1,000 lines of code. So it's not games, it's just to demonstrate it can be used to rule OpenGL or another great framework existing in software.
Is that
okay.
On that screen back there? Is that Elite?
Sorry?
Is that Elite? If you go back one screen, sorry to interrupt, but that screen back with the games, can you go back one slide? Yeah, is that Elite?
Yes, yes, exactly. You can fly, and you can crash at planet.
It's an awesome game.
No matter. It's two Sandwinders.
Yeah.
If you can, but it's no wireframe graphics. It's pure OpenGL with lighting, shadows, and everything provided by OpenGL. It's a light, exactly. Yeah. Spectrum was my first computer assembled by hands.
Yep.
Exactly, I know this. And Ivan Makarchenko was a great fan of Spectrum.
Yep.
Yes. And it's heretic graphics. Also, you can walk. You can walk. You cannot die. You cannot kill monsters, but you can walk around and see what happens around you. It's very easy and a great pleasure to write these stories. Exactly. And CID tool, writing under government project, when IMD sells electronic production line to Russia. So it was a great problem. We have no CID tools for top level chip design.
3-minute warning, 3 minutes.
Okay, thank you. The principle we implement here, it's all of this, it's a C++ Qt application, except the mine screen. It's Fort provided. So it's most program is written in Fort. Most program is written in scripting language provided by Fort. Okay, now this is our mainstream thing. We extend the principle of messaging. Backward message can be sent from Fort machine to Qt. We can start from empty screen and place widgets in real time. Okay, we left Xilinx. This is our bookshelf, and this is my books written for past 15 years about FPGA. What we can do with Fort in FPGA, we don't need to provide a huge amount of calculations in processor. This is a picture for my article in Excel journal. It's more than 10 years ago. So we don't need to target the performance. Stack is a kind of bottleneck. We need to rule hardware accelerators. So Stack's CPU and so processors in FPGA fabric is very perspective way. Several 8 generation of my Stack CPUs are alive. This is very simple interface.
1 minute.
Okay. I will skip some pictures. This is very easy to connect peripherals. This is easy enough to program. Again, it's another language to provide IDE and Fort scripting to provide machine code. Commands are pure hardware. So 1 cycle to every Fort word shown here. Several generations and several devices in production. This 3rd generation. What we have now, it's Wi-Fi, Bluetooth, it's wearable things, wearable Internet of Things. Add-on boards to Xilinx, Kintex 7 with real-time spectrum. And our magnetic resistive 16 channels, so 16 planes of human body. Fort is everywhere. So no other things, no other technologies when Fort inside. To process DSP, to create by scripting these pretty looking waveforms. So we are very pleased with Fort. So my conclusions are here. We can use Fort to write frameworks and domain-specific language. We can use it for blueware or scripting, and don't try to replace every other language we can see around. What we need here is small Fort core and customize it, extensions, targeted every single project we can see around and we feel we can deliver it to our customers. In hardware, soft cores are not our mainstream. It's auxiliary. And this is very good small memory footprint. because stack machine object. Okay, that's all.
We are short on time. We will meet in 30 days again, so you have another moment.
Yeah, thank you. This is my last slide.
Because this is more to get friends together, and after this meeting, we keep meeting together with the SVFIC from Dr. Ting in California, and in the Facebook group. You must enter.
Yeah, I will try.
I cannot take a plane to Moscow to force you. You are a kung fu master. I can't. It's a friendly invitation. You need to.
Thank you. I will try. We still have some problems with registering in Facebook or. So this is my presentation. I can share it to everyone who needs it, and I'm here to answer your questions.
Excellent. Thank you so much, Ilya.
Okay.
Now we go to Germany.
Thank you very much.
Professor Ullmann, Bernd Ullmann, where are you?
I'm here. Yes, I'm not muted, so we could start. It is pretty funny. The Z80 system reminded me of something I built a couple of years ago. Can you see this?
Yes.
Yes. Okay, great. I only see a small inlet of this. This is a small Z80 system I built, wait a moment, a couple of years ago. And you see it's pretty conventional, built with wire wrap. And this system grew and grew. Now it not only has a CPU card and it runs a port of CamelForth, of course. I also have a very simple video controller, which is based on an AVR processor, basically an Arduino. And the video signal generation is done in software by bit banging. And what this system also has is it has a compact flash disk adapter. So I have a real mass memory system on this little Forth system, and I can develop Forth programs on any host system and just copy them to the compact flash card and then run them on this machine. But that was just a little tinkering system. Apart from this, I have not done much with Forth lately, since my main interest, which you can see here, for example, is in analog computing. But I'm thinking about using Forth to control actually an analog computer. You may be, Cosmac ELF was a very nice system too. You may be familiar with the idea of an analog computer. It's a completely different architecture than a digital machine. And the idea is you have a machine which consists of many, many, many computing elements. For example, you have here 4 integrators, another 4 integrators, 8 summers and multipliers and whatever. And the program on an analog computer looks like a real mess, like spaghetti code, since such a machine is programmed by cleverly interconnecting the computing elements. This may sound ridiculous, but it's a very interesting idea and an old idea as well. The advantage of an analog computer is that it's incredibly fast, even faster than some of today's supercomputers, given certain problems. And currently my team and we are working on a highly integrated analog computer on chip. We are already looking for venture capital, and we already have some venture capital. So we have started developing a reconfigurable analog computer on chip. And a very important part is an analog computer as such, as a standalone device, is not very interesting. What you need is a system coupled and consisting of a digital machine and an analog computer. We already have something like this here. That's another tabletop analog computer. And this one has a module. You can see that's the module with the blue USB cable. That is a simple hybrid controller. As of now, this is based on an Arduino on a Mega 2650. And it takes care of all the timing control of the analog computer and setting of digital potentiometers and the like. And the idea is, when we have this on chip, that you get rid of all this cabling, and the reconfigurability of the analog computer will be implemented with tens of thousands or hundreds of thousands of analog switches, basically FETs, in a pretty clever setup. And these analog computers on chip will then be co-processors to classic digital computers. And a real problem which brought me to thinking about running FORTH on the hybrid controller is latency really kills you. Of course, controlling an analog computer with a USB device is not the brightest idea, but it was the cheapest and fastest method I could find to demonstrate this technology. The problem is if you have USB communications, you have latencies in the range of several milliseconds. That is impossible, since typical solution times on an analog computer, even for very complicated differential equations, is in the order of several 10 or 100 microseconds. So the communication latency more than outperforms the performance of the actual analog computer. The next thing we tried was we developed a controller which could be hooked to a PCIe I/O cards. You see the dangling flat ribbon cables. We have some dedicated PCIe controller cards for a PC, an 8-channel analog digital converter card, and a 32-bit input-output digital card. And the idea was to get rid of the USB communication latency. The interesting thing is communicating over PCIe is incredibly slow too. We were not able to get latencies below about 20 microseconds. And that's an eternity when you are thinking in the speed domain of an analog computer. The main problem is the structure of modern kernels. Of course, we have to use off-the-shelf computers because we cannot force potential customers to use some special computer which is completely unusable since it runs a strange operating system. And so the idea emerged, we have to bring all the intelligence of the control of the analog computer to the hybrid controller module. So the idea is a digital computer on which the user sits and will prepare his problem will basically upload a control program to the hybrid controller, and the hybrid controller will then take care of all things necessary to run the analog computer through its paces. And that's the reason why I'm currently looking for FORTH interpreters for Arduino boards. I've seen there are several FORTH interpreters, but most of those which I had a look at look like being in experimental state. So if you have experience with running FORTH on an Arduino processor, I would really love to get in contact with you, since I think that this is a way, at least for these macroscopic analog computers. By the way, that's not just a hobby project. My wife and I, we built these modern electronic analog computers. We are a 2-person company. And since we are the only company producing analog computers, we are the world's biggest manufacturer of analog computers, being 2 persons, a little bit crazy. But there are several universities using these systems for actual research. And some of this research is really interesting. For example, the University of Ulm here in Germany, about 350 kilometers from where I live, they have a system comparable to this one, and they use this system for automatic drug targeting. They are heavily involved in cancer research, and you have a lot of reaction kinetic simulations which are necessary for cancer research. And so this is not so much a commercial adventure, but it is more to enable researchers around the globe, by the way. We have sold one system to a university in Japan. We have customers in France, and most of our customers, of course, are in Germany, since we are sitting in Germany. But all of these customers and all of these applications currently suffer from the incredible latencies experienced via the USB bus. How many minutes are left?
2 minutes.
2, okay. Then a quick run through my house. Wait a moment, I will show you something. Analog computers are I love analog computers, and I have a pretty large collection of analog computers.
You live inside an analog computer.
Yeah, basically I do. What you see here, this gray contraption, is Germany's first analog computer built after World War II. That's the hand-soldered prototype from Telefunken. So that's a one-of-a-kind machine. We have small systems, we have medium systems like this Electronic Associates 580. We have large systems from, for example, Telefunken, that's an RA770.
Wow.
There are tabletop systems, and nearly all of these machines are up and running, so you can just start one of these machines and start computing. And the largest systems are here. That's an EAI 680, which weighs a ton. It was really complicated to just get it into the house. And this machine, that's the last one on Earth. That's a Pacer 700. I'm working on this for now more than 5 years together with a friend. And it's really horrible to get this machine up and running because nearly everything is defective in this machine. It really had a hard time. So you can see that analog computing really is more than just a hobby for me. If you ever happen to be in Germany, honestly, feel cordially invited to visit us and visit the Analog Computer Museum. Thank you very much for your interest, and thank you very much for the conference and for the invitation.
Thank you very much, Professor Ullmann.
Can I ask you, what part of Germany are you in?
In the middle of Germany, about 60 kilometers from Frankfurt.
Okay, because I'm in Oldenthal, about 30 kilometers from Cologne.
That is very impressive.
Not too far. That should be 1.5 hours by car.
I've never seen a collection of anything like that. That's amazing.
I think you must have a very understanding wife.
Yes, it took a number of iterations to find a wife which tolerates a hobby like this.
That is
Lucky
totally
you.
awesome. Awesome.
Thank you very much.
Wiesbaden, that's not too far out from Hanover. That's where I typically end up when I'm over there. So,
okay,
guys,
honestly, come and visit us. I would be glad to see you.
I propose we go to Netherlands to Jos. Jos, are you ready for the presentation?
Okay. Okay, here I am. Going to share my screen.
There you go. It's coming up.
Okay. I have a little, I'm from Holland, and I have a little presentation about what I did and do with my PC. Here it goes. I love to make unusual fractals, especially Julia fractals in the past. And this one looks nice on a t-shirt.
Let me ask you, do you think you can get closer to your microphone, because we hear echo of the room? Otherwise it's okay.
Sorry, this one is a so-called multi-eyed fractal. I got into it by accident, but it looked nice.
Sorry, I'm only seeing a Zoom screen.
I see a
I'm not seeing.
Oh, okay. Still no picture?
Nope.
No.
Oh, that's a pity.
Just says English, Spanish, Dutch.
And do you see anything now?
Same. There.
Try again.
Now it went
Try
away.
again.
You need to get
to share again.
what the thing you want to share has to be on your screen before you share, of course.
And you have to share the first option, which is a computer screen or something, not one of the applications, if that makes sense.
Share. I'm missing something. Even kijken.
Can you bring up on your screen? Oh, here we go again.
Yeah?
Yes.
Now, yes, yes.
Yes.
Yes, it's perfect.
Hi, group.
Even kijken. Start. F5. Sorry. Oh, God.
No longer sharing.
I'm back?
Yes.
Now you're back on that other one, English, Spanish, Dutch.
First slide or not?
No,
No, you're not seeing the slide now. We're back to the Zoom.
Okay.
you got to pick the right window to share.
Oh, okay. Something coming?
No.
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 You got to stop sharing and then.
It says Zoom logo. Oh.
Yep.
And maybe share the entire desktop, and then you can pick the window you want to show.
Press the green button again, Jos. Share screen.
I see option for whiteboard or post and then T.
On below you got the share screen green button.
Yeah, I did, but it doesn't work. I get
Do it again.
No, then I get select a window or an application.
Excellent. Select your window. Excellent.
Select the window, not the application. That's what I always use. It seems to work. The application one is terribly confusing.
Select the window.
Even kijken. Maybe it is this and then this one. And
No. Go back again. And when you first select share, doesn't it give you a choice of different windows? When you first select share, it should see all the windows you have open in your machine. You choose one. How about we skip over and come back to you after you play around?
Yes, we skip you for a moment, Jos.
Okay.
Try to get help over chat if possible. I go to Giovanni in Italy. Giovanni, are you there? Or Fabio, who is presenting?
Fabio needs to unmute Fabio. Unmute Fabio.
Hi everybody.
Giovanni.
Listen me?
Okay, yes, very well.
Mute is terrible. I think that starts Giovanni because he has prepared a sort of mini test, so we can make some comments after. Okay, Giovanni, are you ready?
Yes. I share a window. Okay.
This is a live presentation of the single board computer.
Yes, it's a little board. It's based on Z80. The design was made to help anyone with an easy build. So there is no EEPROM. There is no strange IC, only the CPU, the RAM, and a T-Mega AVL microcontroller that emulate all the needed I/O devices. So it is only for component for IC. Okay, this is the FORTH, the original FORTH that was ported to this board by Bill Westfield, who is the maintainer of the Arduino bootloader, OptiBoot. And this is a small demo that blinks a user LED that is on the board. If Giovanni can show the blinking LED.
Okay.
If you can switch to CAN. Okay. And here there's the blinking LED. This board has a user software key and a user LED that can be turned on and off by software. In this case, the simple program can turn on and turn off with a little delay made by FORTH to show how interface external physical things with this little board. Of course, not only FORTH can be used here. I put here also CPM 2.2 and CPM 3.0, and also Pascal, the system. So all the CPM programs can be run here. And one of these is FORTH under CPM. This is, for example, the boot with CPM3. Then this board has 128 kilobytes of banked RAM. And the banked RAM is managed by CPM, of course.
Fabio, now show the V20 board.
We have 16 hard disks that are emulated inside a single micro SD card. We have, we don't have anything now.
Nope.
Okay, in the board there are also a GPIO like Arduino with 16 input or output ports that can be used by the software, like the user key and the user LED. A sort of Arduino made with the Zeta 80. This is another board. This is the same concept. So there is a CPU and all the support chips are emulated in only one MCU. But the CPU here is a V20. So it can run 80 or 86 executables, but also in 88 executables, because the CPU has a special mode to run, to emulate a 8080 CPU.
Do you have the F83 force running?
Yes.
Yes.
Here it is.
F83?
Using under CPM 8086.
And the editor? You can edit block screens.
This is a Blink demo.
This is the same demo, but here it is running with the 8086 CPU and CPM 86. So we have much more RAM because we have all the possible RAM space fitted with RAM, because also this system have no EEPROM. All the executables is loaded by the MCU.
Okay, I'll show.
So no EPROM, no legacy EPROM programmer are needed to build these things. And there is no SMD, only two-holes technology. So it's easy to build.
3 minutes, 3 minutes.
And here we have CPM 85 running now. If Giovanni can show how to switch from one operating system to another, because this board can have a multi-boot system. This is the editor. Giovanni, can you tell what are you doing?
Okay.
Okay, this is the switch of the operating system, and Giovanni is changing the operating system in real time from CPM 86 to CPM 2.2, and this change also the CPU core, because here the CPU is emulating a 88 CPU.
Can you hear me with a 1 minute warning? Can you hear me?
Yes.
I don't think he hears me.
Yes, he can.
Okay.
This all.
Okay.
Okay, thank you.
Oh, Fabio and Giovanni.
Thanks.
Thank you.
Thanks a lot.
Thanks.
Thank you very much.
Where is Josh? Josh, are you ready, or should we skip you again?
Now, I have changed the setup, but this, perhaps it should work.
Okay, we try, please.
Okay.
Perfect.
That's nice.
Okay, thank you. Well,
Yes.
Lark, I always love to generate unusual fractals. This one fits nice on a t-shirt. And here's another one. It's my favorite, especially the green one. It's also nice for facial recognition software. Even kijken. And later, I did some OpenGL and quoted some sources from Timothy Trussell for G-Fort to Win32 Fort, and it was not using SDL. Now I'm running several Raspberry Pis and a few ASP8266Fs, and as you see, it's nice for Lightning and a digital of a binary clock.
Beautiful, beautiful.
And this is the interface I use. I use a simple template based on HTML and CSS, and I can steer all kinds of things that I want. In this case, it was a window driver, and this is somewhat more complicated. And as you see, I can also send graphics over HTML. Oh, sorry. And then, sorry, yeah, it's a bit short. But there's one thing I would like to show to you. That is how they look. Even kijken. I'm not sure if you can see this one. This is an 8266F after soldering. Now, it's quite simple. You only need a solder iron and then you go. And this is a Raspberry Pi.
We're seeing Giovanni's screen at the moment. Well, that's what I am seeing.
Sorry?
We're seeing Giovanni's screen. You're kind of small. Whoever's in control, they need to make Joss bigger.
Oh, because I'm seeing his screen.
No?
I think you have to unpin.
Run your cursor up to him.
Oh, right. Yep. Got it.
Yes, this is a Raspberry Pi. I made the casing of it's a 3D printer, and as you see, it isn't big. It's absolutely wonderful, and yeah, I run Linux in it. And that was my presentation. Thank you.
Thank you, Joss. So, do you have Forth running on the Raspberry Pi? Is that what you mean by that?
Yes, indeed.
Impressive.
Yeah, it takes 2 hours and then it runs.
Okay.
Well, the next person is free to go as I'm concerned.
Thank you. Okay, who's next?
Peter?
Who is the next?
Hello, Quentin. Are you ready?
Quentin's.
Okay. Yep, Quentin.
Go ahead.
Your microphone's not working.
Yeah.
You need to unmute. Mic is open, but it's not working.
And like this?
Yeah.
That's it.
Okay. Okay, sharing my screen. Okay. Share.
You are in Paris, Quentin, no?
Yes, I am in Paris. You can see sharing my screen.
Perfect.
Yes,
okay.
Yes.
So my name is Quentin in English. You can contact me at Gmail, quentin.quadra@gmail.com, and also I have a GitHub project. With my name or Le Crapouille, you can find it from Google. I'm a Forth newbie, so I'm not very. I don't know very well to program in Forth. I am from my school. I learned C and C++ for Linux, Unix, for embedded system. And recently, I work for Parrot drones. I work for the motor control. I work on several different versions of the drone. For the air drone 1, 2, and Bebop 1, 2, but unfortunately, my firm fell down. So this is the board I work on. This is the motor control. If you see my mouse pointer, there is 4 motors controlled by Cypress PSOC 3. It was written in C, and the advantage of the PSOC, it was kind of FPGA. You can programming with logical gate or Verilog. This is a 6-step motor control. But on the market, we were the only one controlling 4 motors in one chip. Even the Chinese DJI didn't make that. I work principally alone. I wanted to use Forth for test bench for testing the motor. For example, for the propeller to make spin and to control the thrust and the current. I wanted to do that because I working alone, but I was a little scared, so I didn't try Forth. So I keep using C and C++. But Forth, I made in contact with Forth when I was student for the yearly school project in C, because the idea comes from my father. He suggested me to make an application mixing a spreadsheet and for manipulating geographic maps. For example, on the you see, for example, this map is kind of a spreadsheet, Excel spreadsheet, but it's not a rectangular pavement. It's made with a polygon, but also we can use cells, nodes, arcs, and areas. So this is an extension of the Excel spreadsheet, and instead of Visual Basic, we use a force. Because I was a student, it was a good idea to make an interpreter, a force interpreter, because for learning how to make a virtual machine. And so you can find this project was made in 2005 as this GitHub link. Visually, it looks like this one. On the right part, you can write a new force word, and on the left, this is a map, and you can insert force words. Alors, in this example, the force words are not correct because it was a screenshot I made quickly for before the end of the project. But let's imagine if we want an application for different partial differential equation, you can make a word mean, making the mean of values, neighbors values, whatever for a node, for an arc, for an areas. And when you run the application for each cells, we compute the mean and the mean and the mean and the mean, and you can achieve a basic partial differential equation. This is kind of example we could make. Unfortunately, the project ends. I did not finish this part. So the project reborn in 2017 in C++. In GTK, the part was used with GTK. At the epoch, it was GTK 2. Now it's GTK 3. Before it was OpenGL, the legacy version. Now is I wanted to use the core version, but GTK and OpenGL are not very nice. They cannot mix together. They used to work before, and nowadays it's totally broken. So I make lose time. So because the project was a little complicated for me, I decided to split different parts of the project into smaller Git repos, and SimForce is one of the parts of the force. So SimForce is coming from the book Force by Salman, Tisserand, and Toulot. It was a French. This is a very nice book for beginners. This is the one I recommend to learn force, because with this book you can make your own interpreter. This is very well written, and this is of course token force, not directly assembly. While in the example they give assembly, but my force is kind like a P force is a token force. Of course, this is a toy of force because this is slower than P force. But I guess I tried to make a more user-friendly for error message, because G-force was totally unfriendly for me, because when you make an error, it said just error and an understandable description. I also wanted to make something more robust than like Force, the project Force, because I wanted to unbind that instead of Visual Basic. I didn't want Force make me crash my application. So, but
2
this is
minutes.
for the moment an utopia. So my SimForms is in C++ for inheritance to implement different kind of force to have a classic force and a force specialist for geographic. So some ideas is I can load a C function or the data stack manage integer and floats. For example, 1.6 dot plus will return a float values. So I don't have to make a float stack for that. This is, well, this, if you want, this is the C++ diagram class I made for the force. If you want more question, I can ask after. My objective also was to make something colorful. So, for example, the word, the force word makes on the left the name and the token and the definition with token, the bytecode, and the translation of bytecode. In red is secondary words, and blue is primitive. And also I make a debugger, for example, with similar than the left picture with color, and when the pointer, executing pointer is underlined. And you can, because I needed that, because when I developing the force, it was not working the first time. So I needed something, a debugger, to help me to have my first words working. So I made also a GTK version, but it is still in work in progress with a dictionary and the word with color and auto-completion. Well, if you want, well, I don't have time, but I made something to load a C code, C function, for example, OpenGL. They generate a temporary C file that I make I can compile into a shared library that is loading inside my SimForce with a C++ class handling the symbol, and then you can use the C function directly.
Valentin, we are 40 seconds to end.
And if you want to help me on this project, you are welcome. And my goal is to make kind of SimCity with geographic cards, and to make in the cell force formulas and execute, and to have, for example, a little game, because this is also working in 2D and 3D.
Okay.
That's all. And the presentation.
Thank you very much. Brilliant.
Well done.
Guys, somebody of you probably want to make a small break for a coffee, 5 minutes, okay? We come back in 5 minutes.
Sounds good. Yes. Très impressionnant, Quentin.
Sorry.
Peter, I'm going to call it a night for us. Aussies, it's 2:30 in the morning. I think that's enough for us. So I'm glad it's being recorded. I'll look forward to watching it.
Okay.
I don't know if he's still here. Oh, he is, yes.